Good morning, evening, afternoon, everyone. Today we've got a great session on hub and spoke variations with Azure Virtual WAN with the great David. Thank you, David, for coming and presenting to us today.
Thanks for having me. Thanks for calling great also because, well, I'm impressed. I'm not that great. Thanks anyway.
So, no, it's so good. You wanting to share you're willing to come to us, share your knowledge. That's great in my way.
Yeah.
So
Okay.
you.
So I'll take it.
Just take, you'll be on the. Hopefully, you're on the nice list for Santa or good festive gifts this year.
Maybe.
Well, yeah, we'll see. Just some housekeeping just before we get into the topic. So the Learning Rooms has actually been renamed. We are now part of the Skilling Hub within Microsoft Tech Community. And so we're no longer called Learning Rooms, we're called Skilling Rooms. And you can find us under the Tech Community Skills Hub. And then you can go to Skilling Room directory. So feel free to join in the discussion, register and view future events such as this one right there. This will be our last session of the year, so hope you all have a good break. But just a code of conduct. So this is just an inclusive session. Be welcoming. Everyone's here from different backgrounds, learning styles. We're just all here to have fun and hopefully learn something new. So welcome everyone, and I'll be monitoring the chat throughout. So any questions, feel free to ask through. I'll hand over to David now to essentially continue the introduction and dive straight into the session. So thank you again, David, for coming and presenting to us.
Thank you again. Okay, so as Luke introduced already, we are talking about hub and spokes, but variation with virtual WAN. Because, well, hub and spoke is nice, but we have a nice new stuff, well, not so new, which is called Azure Virtual WAN. And I had the opportunity to work quite a lot with it. And I also had some issue. And so I thought it would be a good idea to share that with people. So here is the agenda. So we'll start with a short reminder of what hub and spoke concepts are, because we need to put some basics. Then we'll go along, starting with a simple hub and spoke with virtual WAN. Then we'll add some customization with a custom route. Then we'll add security with a secure hub with custom route. Then we'll go even beyond that with more than one hub, so secure hubs, plural, with routing intent, and I will explain what it is along the way. Right? So this is the first part, and those are mainly my only slide because we'll do either schema or stuff on the portal. So is that big enough? Maybe not. Okay. So to introduce that, I guess everyone is familiar with what is a virtual network. Inside the virtual network, we have subnets, and usually we put stuff in it. In this example, it will be a virtual machine, but it could be anything that is compatible with a virtual network and subnet. Inside the virtual network, VM1 has the capability to talk to VM2 in terms of routing, right? That's easy. That's the default configuration. We are not talking about filtering for now. We are mainly focused on how stuff talk together, okay? As long as we have only one virtual network, everything works fine. But usually we will have more than one because you need to have stuff talking together, and then you add at least another virtual network, okay? At this point, this is still very simple. VM1 and VM2 could talk together inside their own virtual network, but once you add the new virtual network, if you want VM1 and VM2 to be able to talk to VM3, then you need to add this big arrow here, which is called actually a virtual network peering. And what it will do, it will extend the virtual networks together, meaning that the routing configuration will be extended. Okay, so VM1 will see VM2, it will have a route, but it will also have a route for VM3, and reciprocally, you will have a route from VM3 or any virtual machine inside this network to access to this other network. Okay, for now, this is still very simple. What happens when we want to connect more than two virtual networks because we have some shared service, we have some interconnection with stuff from outside of Azure, which we have to deal with sometime. Then we want to mutualize some resource, and usually we will come across a specific network topology, which is called the hub and spoke. Okay, so the hub and spoke is just that. This is one central virtual network which is connected to many others. So in this case, I only have two, but it could be more. In the late example, we'll have more than two, matter of fact. But so we can have many more. Okay. Why do we want to have one virtual network connected to the other? As I said, this is because you want to share stuff in that between all the other spoke, okay, such as well, the outside route. So I mentioned that, so it will be express route, which is kind of costly. So you want to centralize that, so we will connect to other network. If it's express route, it will be other network on premise. Okay, it could be also other connectivity stuff with VPN or other shared service. You know what I mean. I won't extend on that because I don't want to spend too much time on that. Okay. What happened now if I want to have VM1 talk to VM4? I know, because I explained that earlier, that VM1 and VM2 can talk to VM3 and reciprocally. But what about VM3 and VM4? So this is the same case. Here, this arrow represents a virtual network peering, so it would work. Okay. But if you want to have VM4 talk to VM1, it doesn't work by default, because this little arrow, this virtual network peering, is extending the network together, but it's not what they call transitive in the documentation, meaning that those two, this one and this one, are connected together as if it was one, and also this one and this one are connected together as if it was one, but it's not extended between the two virtual network on the top of the schema. So to solve that, we need to add some other thing, which is usually called which is called a user-defined route. So as the name implies, we are modifying the routing configuration inside the virtual network. So instead of having just an extended network where everything is routed, we add a custom route configuration on which we will say, okay, from this network, if you want to access this other network with VM4, you will go through something inside the network that we have together in common, which is able to route the traffic. So it can be a firewall, as represented here. It could be in an even more simple way, just the virtual network gateway that we use to connect with the express route that we mentioned earlier. As long as it's able to do some routing, it has an IP in the virtual network, it can be used as the next hop for our virtual network. Okay, so then this way we have the hub and spoke, and we have a routing configuration with the next hop configuration. Okay, so it's working well. There are some limitations, but it's working well. Okay, the main trouble that we have with this hub and spoke configuration would be this little stuff, this little people with the arrow, which represent the routing. We need to apply that on each subnet. Again, on this schema, we only have two networks with only two subnets, so it would be only 4 application of user-defined routes. But imagine you have 10, 20, 100 virtual network connected to the hub, and then for each of those networks, you have 1, 2, 3, 4, 5. I don't know how many network subnet you could have. Each time you will need to connect a route, verify that it's connected, and be sure that it's updated if you modify the routing configuration, right? So it works fine. It can be done through automation, but it's distributed. So it's good because it's distributed. We like distribution. This is one of the concept of the cloud and its resiliency, but it's also less good from a network administration point of view, because if you talk about that with network people, usually the network guy doesn't want to share his power, and I understand that. Meaning that if you come to him and tell him, hey, you need to configure the router at each spoke level so that it works, and you say, maybe. He doesn't like that, okay? So he will want to do something else, and that's one of the scenarios that we want to explore today. So let's remove the hub and the routing configuration and just migrate to virtual WAN, okay? So we can have just one virtual WAN, which will contain a virtual hub. As the name implied, this is kind of the same as the virtual network that we had earlier, except that it is a managed hub. And inside of that, we'll have routing and router first, and then routing. And all of that will be centralized. But instead of talking about that, let's have a look on how it's working, right? Because that's why we are here. So we are taking the simple scenario, so you can see that I have more than one virtual WAN because I prepared a different scenario. So in this scenario, we just want to change, to move from the virtual network hub, and simplify the routing configuration. So we have only one hub. It's maybe a little small. Okay, so we have one hub, or maybe it's too big now. And on this hub, we'll have network that will be connected. It will be the same as before. It will be peering, but they changed the name, and it's called from the virtual and in the virtual hub. It's called a virtual network connection. This is exactly the same, except that it's managed from the virtual hub, and then it kind of change how it's appearing inside the virtual on the virtual network side, but we'll see about that just after. Okay, so here it's how we can have virtual network connected to that. But before going to the detail of the network, we just want to have a look at the virtual WAN and its virtual hub. So here we can see that we have one virtual hub, or maybe I should just step back. An interesting with the virtual WAN and the virtual hub is that we have a network topology that can be displayed automatically. So here you can see that I have one virtual WAN with one virtual hub, and you can see the two networks that are connected. This is something that is updated directly when you manage your hub and spoke infrastructure topology from a virtual hub, virtual WAN. You have a nice topology that is created with this topology view. Okay, so that's one thing. The other thing, if we go back to the virtual hub, I mentioned that the virtual hub comes with routing capabilities. So you can see it here. As a matter of fact, you can see that we have a private address space, so that's okay. I'll come back to that in a few seconds. But we also have a routing configuration. So you can see here, routing status provisioned. You can see that I can reset the hub and sometimes reset the router. So that means that I can manage that. And if we go into the JSON view, you can see that below here we have virtual router IPs, and we have two IPs. Okay, so those IP are taken into the range that we associated with the virtual hub, really the virtual hub, not the virtual WAN. Okay, so in the virtual WAN we had one virtual hub, and we added this IP range, and then automatically it provisioned to us these router IPs, which are used to do the routing stuff that the virtual hub is capable of doing. Okay. An interesting fact. So you can see here that I chose /23, which means that I have supposedly 112 IP addresses. This is a recommendation from the documentation. You can start with /24, so 256, but Microsoft recommends /23. I'll talk about that after that. At this time, I only consume two IP, so maybe the 23 is overkill, but well, I made that in my configuration of infrastructure as code, so I did not change it. Okay. You can also see that we have the virtual router ASN 65.5.15. We won't touch about that yet. Okay, so there is one scenario about that is not mentioned. We'll just talk about it at the end. And it may be interesting to have this router ASN, which refers to BGP, but for now, we don't want to do BGP stuff. We want to keep it simple. Okay, so I have my virtual hub, and on my virtual hub, let's move back. I have my virtual network connection, and my virtual connection allows me to definitely just create a network peering on my network. Okay, so let's open another window while it's loading. So if you have never managed a virtual WAN, don't be surprised. It takes a lot of time to answer through the portal, but for this session, I wanted to do that on the portal. Okay, so if we check one configuration, one network configuration, we can edit the network configuration. This is the very basic, the most basic that you can do at this point. You can see here that we have an argument stating propagate default route. We talk about that in the third scenario. For now, we are forgetting it. We have the associate route table, which is default. You can see that we have none or default. It's also written propagate to none, not propagate to none, okay? And propagate to route table default, propagate to label default. So we won't talk about the propagate to label, but propagate to route table and the associate to route table is quite interesting for us, okay? So let's keep that in mind for now. Let's just have a look to the virtual network. So we have a bunch of virtual networks, so we need to check which one is the good one. So this is the single no firewall, so this one. So if I go into the parameters, so you've seen that it's already connected. And if I check the peering here, you can see that I have a peering. You can see also that there is a very strange name that no human being would like to do. And if you click on the remote network, you will get nothing, because you can see that the access token is wrong, blah, 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 blah. It means that in reality, this is a peering to something that is not a network that you manage, but a network that is managed by Microsoft in the virtual hub. That's why we have that. But this is still a peering. And when we create one, it will display in the activity log that we have created a peering. But from the virtual network, from the virtual hub point of view, this is called a virtual network connection. Sorry, virtual network connection. Okay, so let's switch to the route table, to the virtual hub, and switch to have a look to the route table. Okay, so here we have one route table. So again, it takes some time to display. Okay, and you can see we have two associated connection and propagating connection. What does it mean? Can we check on that? If I check on that, okay, it's not visible here. This is not what we wanted to see. We can maybe check effective route. Okay, so we can only check the default one. And if we check this route table, we should see a few routes that are explaining what we have connected. So there is no result in it. Okay, so that's all right, because I did not, see, it's coming. So you can see here, I have one range, two range with the next hop type, virtual network connection with the next hop, VWAN single no firewall. So this is the name of my virtual hub. Okay, so let's have a look at something more visual. Here we can see that this first range that we've just seen is actually the range of my network. So if I check on the second one, it will be 172, 22, and 1, and 0, 24. So those are the routes to my two virtual network. Okay, so that means that when I created my connection, without configuring anything, without adding any route table into the virtual network, the Spoke virtual network, I got that because I choose in my network configuration to I choose to propagate everything. Okay, so let's just go back to this parameters, and then we'll have a look at the effective route table on the virtual machine, because you may know that if you want to have view on the applied route for real, you need to have a virtual machine and access to its network cards. Okay. So let's just go back once here. So here you can see it was associated to this default route table, and the important point is, well, or those two one, propagate to none. No, it's not propagate to none, and propagate to route table here to default. And that's why we have this route. Okay. When we create a network connection, we select the route table that we want to associate to the network connection, and then we select if you want to propagate the route from the virtual network to this route table. Okay, so that means that if I go here, no, not address space, connected device, I will get one network card that corresponds to one virtual machine. And if I go in help, in effective route, here I will see, sorry, I know why. I need to overview. That's because I I have an automated stop on my virtual machine. So I will do that like that. I need to save money, so at the end of the day, the virtual machine are stopping, which I forgot. So I need to restart the virtual machine to have the root appearing on the network card. So the virtual machine should be over there, right? Yes, we have a bunch of virtual machines to start. Yes, we want to start that. So hopefully it will be fast because these are very small virtual machine, but you can see here all of those were deallocated, so that's why it was not working. I will go to this.
I like the dashboards that you got configured. The dashboards.
Yep, this dashboard. Yeah. Oh yes, because I'm lazy. So I created that a few years ago, and every time I need it, I just export my dashboard. This is a nice JSON, and I upload that every time, every tenant I go, because at least I have my stuff.
That's a good idea. It's I think I personally need to use dashboards a lot more because it's exactly what you like for the people watching. Essentially, it's really easy to create. You add it and then change what you want, but it's you can do it per application, or you could do something like this where it's just like, here's your key vaults, here's your storage accounts, without going into the all resources list and then having to see everything and then filter it. Like this just becomes a lot more has a lot more context. Yeah, I like it.
You can even add some metrics if you want. So as you mentioned, it can be oriented for an application. And then if you have always the same pattern, you could even try to automate that. So it's not easy to do it at first, but the idea is that you create your dashboard, then you export the JSON template, and then you can find the resource ID in it. And once you have the resource ID in it, you can automate stuff to recreate your dashboard. So I've done that a few times because, again, I'm lazy. Okay, now it's working. So I should have the effective route. No, because it's still not refresh on this one. Oh, still not running. Can I maybe have another virtual machine which is working? So it was... Yes, because I have more than one page. It's okay. I will start that, but the explanation works the same with any virtual machine that is running. So I will take this one, except that instead of having just the true root extended, you will see more root because we have more, maybe more stuff connected to this one. So if I go into the network configuration for the virtual machine, here I can find again my network interface. And in my network interface, again, if you want to have information on the routing configuration, you go into help and effective routes. And here we will see, hopefully, that we have a few routes. So the default route, if we just, yes, we can organize by the source. The default refer to what you get automatically on your virtual network when there is a virtual machine in it. Default means that it comes from the virtual network system root. So no configuration, nothing, it's what you have by default. Each time you add virtual network range, so it will be the first one that you get on top of your routing configuration, and then you will have additional routes, such as for this one, default internet, because I still have not configured the egress network that I should do because it's changing, but that's not the topic for today. You also have a few network that may be familiar, so the one that should be familiar are this one, no, not this one. Oh, it won't be a good example. What you should see are the RFC 1918 range, so 10.0.0./8, 172.16.00/12, and then 192 168.00/16. Those are the non-routable range. And you also have this one, which is the carrier range, and other network that are described in the very nice article from a guy called Aidan Finn that you may have heard about. So if you want to have some more network deep dive in Azure, you should check this guy. Okay, so what I wanted also to show you here is that we have this network peering, which is the network, the route that is extended when we do a peering. And what I got, and now I need to really switch back to the proper virtual machine because the others are not configured the way I want. So I should check this one. Network here. And this time it's working. And here you should see soon, in a few seconds. Okay, perfect. You can see here that you have with the source virtual network gateway, meaning it's coming from a virtual network gateway. The virtual network gateway, in fact, is the router that we have in the virtual hub. And you can see that to access this other network, we will go through this IP. And this IP, if you remember well, this is not exactly the one that we had on the virtual hub, but this is very similar. Here, and in the JSON view, you can see here that we had 69 and 70, and here we have 68. So I would guess that it's kind of a load balancer IP that we get that is in front of our virtual router IP address. Okay. The last thing that we could do on this one is maybe check our virtual machine, but with this time from a network visualization point of view. So we will use another tool, which is, I need to scroll over there, which is Network Watcher. And Network Watcher can be useful if you want to verify the configuration of your routing. So here we will do that. Next hop, which will show me the next hop of my virtual machine to reach another virtual machine. So we'll take this subscription. I will take this one should be good. I will take this one. Okay, and I do know that my IP is .1.4. And if I do next hop, I will get the same thing, as a matter of fact, that I just showed you, which is the IP of my virtual router. And that means that I have routing, but without too much configuration. And most of all, everything is centralized inside the virtual hub. Okay? So that was the first scenario. If you want to move to another scenario, so that's what this one. If you want to have still something simple, but with additional routing rule. Okay, so what can we do if we have we want to have the blue spoke that talk together, okay, and we also want to have the yellow spoke. Well, maybe I can correct that. We want to have the yellow spoke that talk together also, okay, but only together. So how can we do that? Well, we just need to add a custom route. Very simple. This is the same. We have still the virtual hub with its virtual router, and we had the default route that we used to associate it with the network connection, meaning the peering, so that this blue spoke could talk to this blue spoke by going through this router. We want to do the same, except that we want to have a different route so that this VM can only find a route to this other spoke that are in the yellow group. So for that, we just add a new route, and we'll configure it the same way. So when we create a route, so I have another virtual LAN in which I created a route, because as I've shown you already, it takes some time. So I prepared everything beforehand, and also I can avoid the demo effect. And then I configure the network connection the same way that they are configured on the other network, on the other virtual hub. So without further discussion, let's go to some manipulation, because we want to manipulate. Okay, so here I'm still in the virtual WAN here, but I will check this time. I have another one which is called multiple RT, so it should be this one. So here you can see I still have one virtual hub. Okay, I can reduce that. On this virtual hub, if I connect, if I click here, you can see that I have this time more than one route table. So you can create as many routes as you want. If you want to have different group of spokes, you can create more routes. Okay, so let's just wait for it to appear. So you can see I have the default one. You can see here I have the RT yellow spoke, and I misspelled that because it lacks a L, but that's okay. And you can see that at this point I only have one associated connection because I wanted to do the exercise with you. So let's move back here to the virtual hub and to the virtual network connection, and I will create a new connection with you, and then we'll also check that the blue VM can talk together, but they cannot talk to the yellow VM that is already connected to the V1 with another route. Okay, so here you can see that I have 3 routes. Okay, 3 network connections. Sorry, not 3 routes. So we create the network connection, but first, let's associate that to the proper object. So I will select a virtual network. It should be this one. Okay. Still propagate to none. No. Propagate to RT yellow, spoke yellow. Propagate to root table, also this one. And that means that I will create a connection that will be associated with this root table. So that means that we'll inherit the existing root already in this root table, but I will also propagate the root from my network to this root table, meaning that all the connected network using this root will also inherit the new propagated root. So that's why they can talk to each other. Okay, so let's give it a name. What's the name of my network? So it would be net. Let's call it vnet yellow spoke 2. Okay, right. Okay, perfect. So while it's creating, you will see it appear, and it will have a status of updating, if I'm correct. So you can see here, I have 4 now, but 1 which is updating. You can also see that I did not follow my naming convention, but well, I wanted to make it work, so okay. So here in this schema, in this spoke, so this is typically what we have is something like that. So I have each time I have one network with one virtual machine. So I have this virtual machine inside one of the blue spoke, this other virtual machine inside one of the other blue spoke. So what I will check is that they can talk together, but that they cannot talk to this one already. Okay, just to be sure. So how can I do that? Let's go over there. Virtual machine. So it was the multiple RT, so I can take this one. So this machine has an IP 172.22.068, and the second one has 22.1.4, if I'm correct. Is it appearing somewhere? Why don't I? It's here. Okay. And you can also see that I have the third one, which will be the 2.4. Okay. Okay, right. So let's try that. So I don't want to connect to the virtual machine, but hopefully I can do a run command. And I will just do a simple ping from this virtual machine this time. 22.1.4, and if I run that, it should work. Oh, it won't work because I forgot to write a number. So now I need to wait for the error to come. So you can see it was invalid, so I correct that. So I want just to have 3 ping. So this run command is useful if you want to check something on a virtual machine but not connect to it, because sometimes you cannot connect to it. Okay, and you can see here, I can access 3 packets transmitted, 3 packets received. Okay, so now we want to verify that my theory is working. So this time I want to check from this virtual machine if I can access this one. And so here it should be this one. Okay, let's do that. And it should not work. See, 0 received, it doesn't work as expected. Let's just have a look to be more thorough at the network interface card and check the routes again. I could do the network watcher, but I prefer to display all the routes. So here you can see that I have one route that comes from a virtual network gateway. Okay, so I have a route for this network, the one that I make work. But you can see that for all the other network in the 172 something until, well, this other one, I have a route stating none, because I did not override this default route, which comes from the default route table, which is inside the virtual network. So unless I'm specifically propagating the route from another network to the same route table from the virtual WAN, virtual hub, I won't get that into my network on my network interface card. So that's why I cannot reach this this yellow spoke, because even if the connectivity exists on the virtual hub, since it exists with another route table, it doesn't overwrite the default system route that we have, which say that, well, it's not routed. Okay, so that's why it's not routed. Perfect. So I can split my network without adding anything else than just a route table. I still don't have filtering, right? At this point, this is nice. So I can segregate my spoke by adding some route table. It's still centralized. It's still very simple on the spoke side because nothing to do, right? Still no filtering at this point. Okay, so what do I do if I want to do some filtering? So let's remove that and talk about this one. If you want to do some, I should have something else. No, I don't have it yet. Okay, it's okay. It's okay. I will discuss that later. So if I want to add some filtering in my scenario, which is usually what you have in the hub and spoke scenario, I can also add a firewall inside the virtual hub. How it will work? Well, let's have a look. So I can go back again to this place and this place. And here you can see, if the name is quite clear, virtual WAN RTFW, which means that this one I have root table and a firewall. Okay, so this is the scenario in which I want still to use a custom root, virtual WAN and a virtual hub, still not manage in a distributed manner the root, but have add some security, right? So if I check on my hub, you can see here it changed from earlier. You can see that there is the yellow icon here, meaning that it's a secure hub. And you can see here, Azure Firewall is deployed. Okay. If I go over there, I think I can see it here. So yes, there is the firewall. I could add other stuff. Okay. Other third-party product. The easiest to deploy is Azure Firewall. Why am I talking about that? Just so you know, inside the hub and spoke, because this is a hub, the classical hub with a virtual network, you can deploy any virtual machine available on the marketplace. So that means any network appliance available on the marketplace. Is it the same with the virtual hub? Not exactly. If I go over there, you can find a few network appliances, and you will be able to check here the provider that are available. And most of those are firewalls. So we can see here Fortinet next generation firewall, but you also have some other stuff which are SD-WAN oriented. So we don't want to talk too much about that, but just remember that maybe one of the lack, it's not that much a big lack anymore, but one of the lack of the virtual hub is that you cannot deploy everything that you want inside. Okay, we can also deploy some SaaS solution, and one of the SaaS solution that you can deploy is actually Palo Alto. So I just had one occasion to manage that. It's quite well integrated, and it does exist as nearly as an Azure resources. So if you deploy at one point the Palo Alto SaaS solution inside your virtual hub, you will get something very similar to what is a firewall inside Azure, which is this one. If I go here, I have just Azure firewalls, right? But you could have something very similar with the Palo Alto. That's a parenthesis. So here I have one firewall. This is the firewall that was added to my virtual WAN, my virtual hub. It's managed with a firewall policy, but I don't want to check that. Just so you know, I've allowed all traffic for this demonstration because I didn't want to have traffic that is blocked. But the interesting part is that so everything is allowed. Okay, application, we could check that, but everything is allowed. Let's go back to the virtual WAN. And here, how did I configure my hub so that it uses the firewall? Because you've seen earlier that when I create a network connection, I have check one checkbox so that the range for my virtual network is propagated to the root. This way, it means that everything is routed to the router without any configuration. We don't manage any firewalling. Okay. If I want to modify that so that I have a firewall, I can again use a route table, but this time I need to change the way the route table is configured. This is one way of doing it. We'll see after that the last way, which is maybe simpler, but for now, let's move on with that. So this time I have this route table, which is named much more nicely, probably because I did that through automation. And here you can see that I have added static routes. So I have a static route, internet to firewall, where I state that the destination prefix 000/0 is going to the firewall. IFW, V1, RT, etc. You can trust me on that. This is the firewall that I showed you, which is over there. It should be this one. Okay. Right. I also added another one, which is the route to the private ranges. All the private ranges from the RFC 1990 that I mentioned earlier that were either non-routed or propagated to the route automatically. This time I've changed that, and I'm saying that this route, this range should go to the firewall. But if you remember what I've shown you earlier, when I create a network connection, I have the range from my network, which is propagated to the root, and which is using the default router, so not the firewall. And because usually the range is smaller than this big range, it would mean that this route configuration would not apply because my other configuration will be more accurate, more smaller, so it would not work. Okay, so how is it working? Well, that's because we change the way we configure our network connection, and that's where the none that we mentioned earlier will come useful. Let's have a look if it wants to charge. Okay, so here you can see that I have 4 network connected. If I go into network connection here, you will see that it's a little bit different. So this one is not the one that I want to see. This is this one that I want to see. Okay, so this one is associated to the route table that I showed you earlier, which is configured with the firewall. And you can see that this time I said propagate to none. And because I said propagate to none, that means that I do not propagate the route from my virtual network to this route table. So this route table doesn't have any route that is added with the network connection. It only has the static route that I specified, meaning that everything is going through the firewall. Okay. So if I check one of the virtual machine of this this spoke, so let's go over there. It should be here. RT firewall, but not this one. It would be this 3. Yep. So again, if I go in network, into the network interface card, effective routes, and this time we should see, yep, so we have the peering, okay, we have the route of the network, and all the other route that were appearing automatically are erased because this time I have a much more secured route, let's say. Everything is going through this IP, which is the IP of the firewall that I have here, okay? So I change the route propagated to the network interface card by the network connection by configuring my custom route table to not propagate the route from the network, the virtual network that are connected, and by adding some static route. This time, that means that I will go to this firewall to have to reach another virtual machine. So if I go into, well, let's go to the firewall. I prepared some traffic earlier, so this time, if I'm going to the logs, here I should see that I have traffic coming from, which IP was it? Overview, it should be the 2, right? Yes, this one. Okay, so if I go back here, oh, but this one is good. And this time you can see that those are the logs, the traffic logs on my firewall. You can see that I have traffic coming from my my virtual machine that are going through the firewall. So indeed, my firewall is in place into my virtual one. Okay, so I change the way I use my routing configuration. This is still centralized, except that instead of having something dynamic, I broke the dynamic propagation. I specified something that encapsulate all the routing that I want to have, and I choose to force that to make it go through my firewall. So it's working fine as long as I have one hub and not too many exotic networks. So if I have some network over there that do not respect the RFC 1919, I need to also configure my route table over there. It will work. What happens this time if I want to have a second virtual hub with a second firewall? Can I use a custom route table as I did on this one, which is not represented? If it's not represented, that's for a good reason, because it doesn't work. Because remember, on the route table here, I added a route stating that all the network that are the private network are going through the firewall. So how can I tell him that if he should go to this blue, if this blue network was connected to this hub and this one to this other one hub, how would I tell him that once he's here, he should go to this one? It doesn't work because I broke the dynamic propagation. So I need to recreate some dynamic stuff. And fortunately, that's something that is available with the routing intent. Okay, so I don't have a schema for that. That's my last scenario. So I think I have this one. Secure hubs with routing intent, right? So this is this one. Let's go here. Yes. We need the firewalls. And let's go here. This time here. Okay, so this time we'll go to this one. So this one is the original virtual WAN lab. So that's why it doesn't have a very nice name. But here you can see that this time we have two virtual WANs, virtual hubs. Okay, those two virtual hubs are secured hub with firewall, and those two virtual hubs have only one root table, but they are still using the firewall, right? Let's just show the root table, and then we'll go into another section of the routing configuration in which we'll see that it's working differently. So here you can see that I have associated connection 4, okay, and propagated to none also 4. So how is it working? That's because this time I'm reusing something dynamic, which is the routing intent. So the first time I used the virtual one, routing intent was still in preview, so I did not use it on my first client. And now it's available, it's GA, so use it. It's much more simple than adding some custom routes, except if you need the scenario with custom routes. But this time you can see here that I create policy. So I have one policy for the internet traffic, one policy for the private traffic, and I'm telling it to go to the firewall. Right, so this is on the virtual hub 2, so it goes to the firewall 2. If I want to add additional prefix, I can. I don't need to, so I did not do it on this time, but I could. And then it would force some non-conventional private traffic to go to the firewall instead of going to the internet. Okay, and by doing that, if I take a step back and go to network connection, here you can see that the network connection are showing something a little bit different. Come on. Okay, so you can see here I have 3 network connection on this one. Oh, that's funny. Why do we have 3 and not 4? And I have 4 on this one, but you can see here the routing properties are using routing intent. Okay, so if I edit here, so you can see that I have associated to root table. Everything is grayed out because I'm using routing intent. So I'm not really configuring the routing the same way. Okay, maybe you can check another one. Yeah, this one. Okay, perfect. This is exactly the same. What did I want to show you here? This last button. This one, propagate default route. What does it mean? The name doesn't mean anything. But in reality, this is quite important. If you check this button, your virtual network will not use the default egress configuration. It will use the egress from the firewall. So you will go through the firewall. So if the firewall doesn't allow egress traffic, it won't be allowed. Okay, and this property is not very clear. As a matter of fact, just so you know, it also exists on something over there. On the Terraform configuration, it doesn't have the same name. So if we go over there, I should have in the network stuff. I will zoom in afterward. Network. Network. Virtual Hub Network Connection. It would be this one. Routing, propagate route table. Yes, this is this one. So this one is maybe much more clearer. So on the API side, which is reflected here on the Terraform configuration, but if you check the API, it will be the same. You have internet security enabled, it default to false. If I go back to my network connection, this is this parameter. So if you want to secure your network connection for your spoke so that it goes through the firewall, you need to check this button or to use the API to configure this parameter. So that's something that unfortunately happens when the API evolve, when the product evolve, it will change on the portal, on the display that we have, us human being, it will not change on the API. And so that's why it's not really easy to understand what it is. So I don't know why they call that why they call it that way. So this propagate default rule is the way we configure the internet security for a spoke that is connected. Okay. So just before concluding that, because I'm at the end of my scenarios, I want to go to the firewalls over there. So I want to check that I have. So remember on this hub, I have 3 network connected to one hub, 4 network connected to another hub, and all of these 2 hubs are using routing intent so that all traffic for private traffic is going through the firewall. So in theory, I should have traffic going flowing between all the firewalls for one virtual machine or another, so that it means that the 2 firewalls are connected, because the 2 hubs are automatically connected, right? So if I use this query, so I just use the query so that I could specify the source IP and destination IP. So you can see that I have source IP going to this destination IP. It's going through the firewall, and we will see something very similar over there, meaning that it also goes to the firewall. I don't want this simple mode. I want this one. And I have something similar too. Okay, so all the 172.20 something, all the traffic that I did before this session with my virtual machine, and all the other traffic, as you can see here, those are the IP of either the firewall or the router that are talking together. Okay, so in this last scenario, we added a new virtual hub, and this virtual hub is connected to the previous one. But because we could not use the custom route for the firewall, this time we change back to something more dynamic with the routing intent. Okay? So that's all for the scenario. So starting from very simple, you can connect everything together and then add some custom routing on some firewall, everything, depending on your scenario. But you see, you can keep it centralized, which is something that will please your network guy. And that's why I had to do that, as a matter of fact.
I like how Virtual WAN makes just the routing a hell of a lot easier as well, without having to define user-defined routes all over the place.
Yeah. And there is always someone who is very smart that says, hey, what happens if I remove this route? I don't go to the firewall. And it's perfect. And then it's, oh, come on. So, well, see what I mean?
Yeah, with great power comes great responsibility, right? Yeah.
Exactly.
There's no questions in chat, but thank you very much for coming and presenting these scenarios today. Definitely food for thought, learn something new. But yeah, thank you for giving up your evening to come and chat with us today.
Thank you for inviting me. If you want to read that, we discussed that before the beginning of the session, but everything is written somewhere in my blog. So you should find that over there. So I can give you that. Multiple firewall and routing intent, the last scenario. This is over there. Is there somewhere where I can copy paste link? Yes, I can do that.
Yeah, there should be chat on.
Yep.
So I'll grab that and I will put it into the public chat.
Perfect.
And then show.
So this is the written version of the last scenario. I also have a few other things, but I don't want to paste too many things. But if some people are interested, everything comes from the documentation. Actually, so it's just that because I need to have some rewriting for me, so I write some article. But you can check, you can find all of the information that I shared tonight or this morning, depending on where you are, inside the documentation, the Azure documentation. The way it's organized may be more relevant for people depending on how you think. For me, it was useful to rewrite that, but that's just me.
That comes with your own experience and your own expectation. But yeah, if you've run into the problems and needing to write this, most likely someone else has run into similar problems and asking the same question.
I guess so.
Yeah, well, we hope. Yeah. But thank you for coming and sharing us today.
Thanks for having me again.
In the stream. But just for the people who are watching, this is the last one of the year, but definitely make sure you check out the skilling rooms. We've got Season of AI scheduled for mid-January. We're still working through that, but there'll be a lot more sessions and events going into next year. So thank you very much. Have a good one.